Hello, today I'm going to give you a brief tour of TagViz. TagViz is a system we developed using Maya that allows us to visualize three-dimensional tag data. So this is some actual data from a Weddell seal diving under the ice in the Antarctic. It's color-coded for stroking rate. So purple is a stroking rate of 0, and red would be a stroking rate of, in this case, 1.3 strokes per second, which was the top end of this animal, at least for this dive. At the bottom of the screen, there's a timeline, and as we move back and forth through time, you can see there's a red marker moving along the path. That represents the current position of the animal. So if we wanted to check, for example, where the descent phase ended, which is right about there, we could zoom in and move till we get to just the right point. We can see at the top of the screen on the heads-up display, it shows us the current position. That's X, Y, and Z coordinates and the current time. So we're at about 268 meters down and at 4 minutes 31 seconds. Then if we zoomed out and fast forwarded through the dive here and wanted to see where the ascent began, at that point we're 419 meters down and 10 minutes 29 seconds have elapsed. And then we could go to the end of the dive and see that the whole dive was about 14 minutes long. So one of the cool things about this dive is it really clearly illustrates the burst and glide technique. You can see purple is a stroking rate of 0. Green is pretty low. So you can see that on almost the whole way down to about 300 meters, the animal's conserving energy by just gliding and then making these tiny little corrections. And then on the way back up, it makes almost a perfect straight line back to the hole in the ice where it started, and it picks a very consistent stroking rate. So down here between about 300 and 500 meters is the hunting area, and the points where the animal encountered prey are indicated by these white spheres. If we wanted to look at something more closely, like this area down here where there were 3 fish really close together, we could select the marker, change the camera's focus, and then we could orbit the camera around that point to get a better look. So now let's start taking some measurements. Here I've hidden the dive path so we can concentrate on those targets. Those are the points that the animal encountered fish during the dive. Let's pop out to the top view and move this cube over the target area and then resize it so it fits around that area tightly. And then we can measure this cube and get an idea of how big that volume is. So here I'm skipping ahead, but we can look at the scale, multiply those numbers by 100, and we get 2.9 million cubic meters, which would be a decent approximation of the size of this hunting area down here. So now I've used the measurement tool to add 5 distance measurements. So we can take a look at what an annotated version of this dive might look like. So let's pop out to the front view. And here we can see that the total horizontal distance traveled was 472 meters each way. The deepest point of the dive was at 488 meters. The shallowest fish was at 332 meters, and the deepest one was at 477 meters. So now let's pop out and take a look at the ascent, and this is where the animal really made the most energy investment to get back up. So measured along its length, the ascent was 496 meters long. So another cool thing we could do, just to get a sense of scale, would be to take a look at our seal model in comparison to the dive path. So here's a life-size seal. She's just a little over 2 meters long. And if we zoom out, we can just get a sense of how enormous this space really is. And that's one of the reasons why we use the marker, because if we had a realistic seal model moving along the path, you wouldn't even be able to see it at this distance. So that's TagViz. I hope you enjoyed our little tour. Thanks for watching.